Good morning, ladies and gentlemen. My name is St. John Holloway, and we are here to talk about this delightful contraption here, Water for Life atmospheric water generator. There are three ways that it works. What it can do is it can generate water right out of thin air. I know that sounds like magic, but that's what it does. It pulls air in, it cools that air, expels the hot air out the back, and then as the air passes over those coils, it condensates and it causes little beads of water. That water is then collected in a catchment tray and then filtered through a series of several filters, and out comes water. It's a fun way to create water out of thin air, literally. Another way that it works is you can plug it in and connect it to your sink or your faucet, and you can just filter the water straight out of the city lines or your well or any other source of water that you have, a rain barrel, something like that. And then the last way is that you can actually take any form of water from a lake, a puddle, a stream, a bathtub that you filled up, and you can pull out the back tray and you can just pour it directly into the machine and it'll just filter it through. So 3 different ways that you can use the machine.
Does this machine filter salt water?
This machine actually does not filter salt water. It does use an RO, or reverse osmosis system, which can be used to filter salt water, but this machine is not designed to filter salt water. The main thing that this machine is designed to do, besides create water out of the atmosphere, is actually one of the most important features, and that is to raise the pH level and to ionize the water. So it allows you to have, through natural processes, not using electricity, a higher pH or alkaline water with a higher negative ARP reading.
Is there a certain humidity level that it needs to be at or anything like that in the air?
The unit will work in all humidity levels. As long as there's humidity present in the air, there's moisture that it can pull out. But to really see it work well, you want to be at about 45 to 50% humidity and there on up. And the great thing about the machine is that it actually tells you right on the front display what your relative humidity is for wherever the unit is sitting at that time.
So if it pulls the humidity out of the air, it's actually a dehumidifier as well.
And there we go. That's one of the bonuses of it. If you live in an area that's really, really humid and you have problems like mold and lots of moisture in your home, this will actually pull the moisture out of your air and keep your home drier.
In an area with average humidity, how much water will it make and how long will it take to make it?
If you are in an area that has 50% humidity, you're going to be making about 5 gallons per day in a 24-hour period. And as the humidity increases, obviously the volume of water that you create increases as well.
What's the source of power?
So you can power this water generator, is what we call it, either plugged right into an AC wall outlet, so any outlet in your house, a generator, or even the fuelless generator that we have as well. With the fuelless generator, obviously you're going to be using it more in an emergency setting because you need to filter water so that you can use it as drinking water. I just lost my mic there for a second. With the fuelless generator, obviously you'd use it in an emergency situation so that you could filter water and have clean drinking water. Otherwise, just plug it into the regular wall outlet and that'll run it just fine. All right, so the second thing we're going to talk about are some of the main features of the atmospheric water generator. The first thing that's really important is that it has a microcomputer, all right? So when you get this package, you take it out of the box, you plug it in, and you're going to turn it on, all right? So you're just going to put your finger on the power button here. What will happen is the screen illuminates. You're then going to take your finger and you're going to put it on the mode button. So if you can just see that there, the mode button. So we're going to put our finger over there. And then you're going to press the button next to it called set. And you'll see that it says AWG on, which means that the atmospheric water generator is on. You'll also see a little sign here that flashes and says generating. Okay, so what it's doing is it is now going to activate the condensator and it's going to cause it to pull air over it and create water. And that's about all you really do. There's a couple of other buttons there, very, very simple. One is to get water, and one is to change the temperature reading from Celsius to Fahrenheit. So it's in any nation. Look at that. This is all made possible using a microcontroller. It will monitor how much water flows through the filters, when the filters need to be changed, as well as what the humidity is. All of the different things that make this unit work are all controlled by that microcomputer. We've designed this specific unit to work at a much better energy level. So we've incorporated several things that will save energy, and that's so that we can use it with the fuelless generator in an emergency and filter water without using too much power. The other thing about all appliances is that sometimes they'll leak, something will go wrong. The system is really, really intelligent, and what it does is if it detects a leak because you've got too much condensation or anything like that, it actually turns the unit off. And in the back, you'll see that there's some drain holes. You just unplug them. They're at the bottom there. It just has a little white cap. I'm going to point those out to you if you can see it right there. You just unplug those, tilt it back a little bit. It'll drain all that water out, change out your filter or whatever's causing the problem, and the system will turn itself back on. So it's very easy to use. It really looks after itself. And then the most important thing about this system is the filtration. The filtration is really, really important. It's a multi-stage filtration system. So we have a catchment box right here. And what happens is you've got your coils in this area right here, and they get the beads of water on them, and they drip down into the catchment tray. So if you were to pull this catchment tray out, you would see that there's a couple of things that have been caught here in this little filter on the top. There are actually 4 filters in this little space about this tall right here. So there's a mesh filter to catch any larger particles and so forth, all the way down to a carbon filter. And the whole point is to get any impurities out of the water, any physical impurities. That then stores the water in this area right here, okay, and then it pulls it using a pump through these filters. And there you have a pre-stage filter, a post-stage filter, a reverse osmosis filter, and then a TCR filter inside. Now what these different filters do, these filters remove heavy metals, chlorine, anything that's going to cause you to have bacterial infections, anything like that. You know, it's going to get rid of all the impurities out of the water. The RO filter then cleans it up, makes it taste great, removes colors, more chlorine, you know, and more solubles if anything has gotten through, solids, sorry, not solubles. And then the final filter is what I call the little piece of magic. It's actually a mineral pack, and as the water flows over the mineral pack, it absorbs those minerals and it raises the natural pH of the water. So it's not an electronic process, it's an actual physical contact process where over a certain period of time, as it flows over those minerals, it absorbs the alkalinity, it changes the alkalinity of the water and makes it a higher pH. And then we come back to the other side, it all comes out, you just press the water button, and out comes water. Now this unit here was sitting in about 70% humidity, and was completely full within about an 8-hour period. There's a lot of water in the air down here, which is wonderful.
How often will you need to replace the filters?
The shortest period of time would actually be on the first filter, because it's going to be the one that takes the most assault when it comes to contaminants in the water, okay? And that's a 3 to 6 month period. The second filter is 6 to 9 months. Then your RO filter, which is the large white filter, is anywhere from 1 year to 2 years. And the internal filter is 1 year to 2 years as well.
And so, just to be clear, what we're looking at right now is actually 2 different units. We're looking at the front of one and the back of another.
That is correct.
Are those 3 filters, are they pretty easy to detach?
They are simple to detach, and I'll actually show you that right now. As you can see here, there's a beam across the top where the lid of the filter is clipped in, and then there's a little clip at the base. So if you just pull this base out towards you, and you twist it anti-clockwise, that's towards me, and out it comes. And as you can see, there's a little bit of water in there. It creates a little bit of pressure. Put it back in. It's the exact same thing. You're going to put it in, and you're going to twist it clockwise, and just push it right back into that clip, and you're all done.
That was very simple.
It is a very simple process. Another thing to know about the filters, and this is really important, sometimes we're not sure how much time's gone by, we've been on vacation, we've been on a cruise, we've been working, whatever it is that we do. This system actually monitors how much life is left in each filter, how long they've been working, how much water has passed through each filter. It's really easy to get there. What you do is you tap the power button so that the screen illuminates. You take your whole finger and you hold it over the mode button. All right, you're going to then lightly tap the mode button again. My fingers, there we go. And you'll see filter 1, filter 2, filter 3, and you'll see that it says 0, 0, 0. That means these filters have had 0 water pass through them. All right, and that's because we've just changed them out. Now, if the filters had water pass through them, it would read a number up to 100. At 100, this little symbol right here, if you can see it, there's F1, F2, and F3, and it represents those 3 filters, will flash. And that means that you need to change the filter. Once you change the filter by just pulling it out, twisting it in, you would just press the set button when you see that, and it takes it straight back to 0 again and starts the whole process for you. So you don't have to worry about knowing what filter needs to be changed, when it needs to be changed, because the system will actually tell you how to do it.
How much water does the unit hold?
So this unit will actually hold about 1.5 gallons of water, and it stores it in a stainless steel tank at the top so that you don't have any risk of rust or contaminants or anything like that.
Are these filters expensive to replace?
You know, they're actually not that bad to replace. Your typical reverse osmosis filter is about $150 for a really good one. The donation or love gift for these filters is significantly less than that.
Will there be a warranty?
There is a warranty on the unit, and actually we've worked really hard with our manufacturers to make sure that we have something that is really good for people if they're going to donate or get this as a love gift. The actual unit itself is covered parts and labor for 1 year, but the most important part of the unit, which is the condensator and the pump, are covered for 2 whole years.
Does this water generator have to be plugged in for it to filter the water?
Yes, it does. So there are 2 components that are run off of electricity in this unit. The first component is the condensator. It's basically, in simple terms, it's like an air conditioner, okay? It pulls air in, cools it, and because it cools it down, it creates condensation. That's why sometimes you see your air conditioners leaking. The other part that it needs to function is it has a little priming pump, and that pump is what pushes the water through the system and also pulls it on the back end so that it stays at the same rate of flow, so that the filtration system works at peak performance.
Is the water like at a controlled temperature, or does it come out at like the room temperature?
So on this unit, one of the things that we had to take into consideration is that we had to create energy savings. So we've removed the chilling feature, so it will not chill water, and we've also removed the heating feature, it will not heat water. So the water is going to come out at room temperature, and you can store it in a little filter container or whatever you have in your fridge, and just keep the water cool in your fridge if you wanted to do that.
How much power does the water generator take?
Okay, that's a really good question. As I mentioned before, there's 2 things that take power in the unit. The first one is the condensator, and the second one is the pump. The pump will actually use, at a maximum, 350 watts of power. Okay, so it takes quite a little bit of power when it's generating water. When it's just pushing water through, you're under 100 watts. It doesn't use a lot of power to pump water, which is great if you're trying to filter something in an emergency. Your fuelless generator will run it for a decent amount of time, which is really helpful when you don't have any fresh drinking water.
What would be the best location in the home or outside of the home to put the unit?
That is an excellent question. This unit pulls water out of the air. So we've talked about 3 different ways that we can filter water or receive water out of the unit. So let's focus on the atmospheric portion for a second. Okay? If you have a home that has a lovely air conditioning unit and everything's nice and cool inside, guaranteed it's going to be a drier environment because it's designed to keep the humidity out of your house, all right? So if I put it right underneath the AC unit with cold air blowing on it that's dry, it's not going to produce as much water. One of the things that we tell people, if you're going to keep it in your home and you're going to run your AC, keep it in an area where there is still some natural moisture. A kitchen is a very good place, a laundry room is a good place, because you're going to have some natural moisture in the air. Another place, if you didn't want to keep it inside the house where it's going to be drier, is you could keep it in a garage. You could keep it on your porch if it's covered. You don't want the unit to be in direct sunlight. You don't want it to affect how the unit works, and you don't want it to use too much power, so keeping out of the sun is always a good idea. But a covered porch, anything like that where it's got access to the air, is a great way to make sure that it'll function as well. And then also, if you want to keep it in your home but you want the benefit of the moisture from outside, keep it close to a window. You can always open that window up, it can pull in that moisture it needs, and it can create more water, but it still stays inside the house. So it's up to you, but those are the three different suggestions that we usually make.
Let's say you put it outside and it's next to a barbecue and it gets smoke into it, or it's in a place where there's a lot of smoke. Now, is that going to build up in the unit and need to be cleaned, or?
So the smoke, if it's heavy smoke, it's going to get on the outside of the unit, but any air flowing into the unit, and this is why this is such a good question, it's filtered through a few different ways. We've just covered the water filtration, but as it pulls air in, it has to pull air into the unit somehow and expel it. It actually has a micron filter on the side that's patented, and it's a multi-stage carbon filter, and what it does is it removes all of those particulates. Okay, there may be a hint or a smell of that coming through, but the actual physical soot or the black substance that obviously you get with smoke is going to be retained in that filter. Really easy to clean. All you do is you pop that off, undo it, and rinse it underwater. It's very, very simple. Then, if you're worried about any smoke getting into the actual drinking water, if by some miracle there was a taste to it, which there isn't going to be because it's condensated water, the third filter, which is your RO filter, the large white filter, not only removes color, but it also removes odor. That's why it's such an important filter. So it's going to take anything that's in there and extract it out so that you're getting a clear, crisp tasting water that doesn't taste or is contaminated with the smoke from either a barbecue, smoking, any of those things.
Yes. Can it filter water from anywhere, from a lake or a creek?
It can. As I mentioned earlier, we have that catchment tray in the back. So if I had lower humidity, or I didn't have that much power, and I wanted to filter some water, all I would do is I would open up this little catchment tray here, and I can pull. Pretend this is creek water. Okay, use your imagination. And I can just slowly pour that water right in to this catchment tray. And you can decide how much you want to put in there. This will hold about 1.5 gallons of water, as we said before. And once I've put all of that water in there, we're going to get it all in there without spilling. So I'm sure everyone will appreciate that. Let me just do it at the side so you can see what I'm doing. And I can actually hear right now that it's kicked on. It's starting to filter this water. There is a little sensor in here, and what that sensor does is, as water is passed in, it moves that sensor up and it touches a contact, and it tells you that this bottom tray is full. All right, and you can see that on the front of the unit. You see those 2 white lines on the bottom? That is your bottom holding tank, and it's telling us that that's the level of the water in the tank. It then gets pumped through, using the pump through all of these filter systems, and it gets stored in the top of the tank over there. And you can see that top one is flashing because it's getting filled up. Obviously, they're different units, but that's what they do. They just take the water from the bottom and put it in the top, and that's where they store it. And like I said, it's in a stainless steel tank so that antibacterial, all those kinds of wonderful things. But here is one of the benefits, or one of the great features of this unit that I really, really appreciate. After the water is sat there for a while, it recirculates. So you never have to worry about having to pull the water out as soon as it's made for fear that it'll sit and it'll get contaminated over time. The system continues to recirculate that water every several hours so that the water is refreshed, it's re-cleaned, and it's always ready to go. You don't have to worry about that. As long as it's plugged in and it's working, you're going to get clean water whenever you pull it out, which is a really good feature. We're going to go on and talk about reverse osmosis. There are a lot of systems today that you can have installed in your home. They're usually under your sink, and you'll see a couple of white filters and then one blue one. They usually always make it blue for some reason. And these are reverse osmosis systems. Okay, now a reverse osmosis system is a very complex system, and I'm going to try and give a very simple explanation of how it works. Basically, you take water that's under pressure, and you force it through a very fine membrane, and the membrane causes the liquids to go through and the solids to remain behind. Now, when I talk about a fine membrane, it's so fine that it will remove odor, it will remove color, it will remove solid particulates, bacteria, things like that. It's a very, very fine membrane. As the water is forced through this membrane, it comes out completely pure on the other end. I have to restate that. It comes out pure on the other end, and then the water that is not pure is then dumped out. Okay, so that's how a reverse osmosis system works. We decided it was the best system to go with on our unit. We have tested several different systems, ones with just filters and no RO, but the taste of the RO and the way that the water tastes after it goes through an RO, there's something about that that's just really refreshing. It tastes really good. And on the back end, we wanted the water to be completely scrubbed, is what they call it, before it went over the minerals so that we could raise the pH. So it's got a very nice, crisp taste to it, almost like clear stream water. I don't know how to describe it. We'll have to taste some a little bit later. But that's how an RO system works. We have worked very hard to make sure that we have a well-known system, RO system. It is produced here in America with great quality standards. It can be looked up and you can see all the information about it. We are now going to talk about pH, all right? The power of hydrogen. Now, pH is the range of water's acidity through alkalinity, okay? So it's either got lots of acid or it's got lots of alkaline, okay? A natural pH, or sorry, not a natural, a neutral pH is 7, all right? So that's right in the middle, and it's a scale from 0 all the way up to 14, okay? Now, we've actually done some testing over here to look at a couple of different substances and what their pHs are, which is always kind of fun. But what we're going to do is we're going to take some bottled water, okay? And everyone listen really closely. You hear it break open. It was a sealed bottle of water. That's really important to establish. And we're going to test the pH of this water. So we'll just pour a little bit in here. And we'll have a little drink as well. Tastes good. And we're going to see what the pH is of this water. So this is just a regular brand of water that you could find in a store. All right, this is a little pH and ORP tester, okay? This goes in and it measures the pH of the water. This is a rather expensive little tester. They're about $400, but we want to make sure that we get the most accurate reading. So we spend a little bit of money. That's the beauty of science. All right, so we're just going to gently stir the water. Okay, and as you can see, if you can zoom in on that a little bit, I'm just going to let it sit there now. Well, we'll stir it a little bit so that it can settle. And I'm just gently stirring it to make sure that the water surrounds the little meter down there so that it's getting a good, clear, clean reading. I'll remove my hand and you can kind of see what I'm doing there. All right, we're just going to let it sit for a little bit. So we're sitting right now at about 5.83 pH. So we are, if 7 is neutral, we are slightly acidic. Okay, so we're going away. We're 1 point away from neutral. Okay, so this is kind of important. This is just regular water. Growing up in Africa, this is what we drank. We always drank filtered water. It was just the way it is, when there wasn't a good supply of water bottles, we would actually boil all of our water and then run it through a filter so that we'd get the bacterial as well as the solids. That was always a big deal for us. So it's a natural choice. We buy water at the stores. So there we are. We're settled at about 5.84 pH. Okay. Now, that's slightly acidic. It's not alarming by any means, but that's what the water is. So now let's try a favorite. Who here, and by a show of hands, drinks soda? I won't tell anyone, I promise, except everyone is watching. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's quite a few people that drink soda. So we're going to do a little test. We're going to measure the pH of some soda. We won't name it. We'll call it the brown liquid. We're going to put it in to this soda, and we're going to stir it around, and we're going to see what we get. It's going down pretty quick. We are down to 2.64 pH, so we are half again as much acidic as we were with just the plain bottled water. So we're pretty acidic. You know, I think there's a reason that our parents always tell us to brush our teeth before we go to bed, especially after we drink things like this. All right, let's clean that off. Okay, so now, as a contrast, we're going to pull some water out of the atmospheric water generator. Now, all of this water has been produced using moisture out of the air. This wasn't plugged in, or it wasn't staged or anything like that. This is just water straight out of the air. So we'll take a new glass, we'll put it under there. We're going to just press the water button here. As you can see, the water just flows right out. And we're going to test the pH level on this. So I'm going to put it in, stir it around. Let's see where we go. All right. So immediately we're at 9.4, which is quite phenomenal. We're going to keep on going, and we're just going to let it sit there for a little bit whilst we talk. But 9.45, we've raised the pH significantly. Okay, we've gone from a bottled water at a 6, just below a 6, to soda at just below a 3, to water that's been run through our system and over a proprietary set of minerals so that it can absorb and change the pH, and it becomes let's see what we've settled at right now, a 9.48. So you're going to see, regardless of what area you are in the country, about a 9 to a 9.5 pH coming out of this unit. We're going to talk about the benefits of pH a little bit later, but this was just to demonstrate, you know, what do we put in our bodies? Sometimes we don't even really know, you know. When you look at a pH scale, all right, now that we've kind of looked at this, we can talk about how that works. For every point that you go down or up, you increase or decrease by 10 times. Okay? So if I'm at 7 and I go down to 6, I have increased the acidity by 10 times. And if I go from 7 to 8, I have increased the alkalinity by 10 times. So if we start at 7, which is neutral, and we go down to a 3, that's quite a bit. We've increased the acidity a lot. You know, that's 4 times. 4 times. So it's important to note that. We're not talking about small changes. We're talking about pretty significant changes by just a point of pH in either direction. Okay? Who here thinks it's a good idea, after being in the sun, playing sport, going on a long hike, doing anything that's physically demanding, to hydrate afterwards? By show of hands, how many people here think it's pretty good to drink water and hydrate yourself? It's really important to hydrate yourself, okay? Now, one of the things that is a little unknown fact, water water in its natural state, in the streams and the creeks and the lakes and all of those places, as long as it's purified, is actually a smaller molecule, okay, or a smaller set of molecules. We absorb it better because it's more of a natural to slightly alkaline state, okay? So the absorption rate is much better. Smaller molecules, better absorption, all right? pH 9 to 9.5, anywhere from the 8.5 to 10 range, has the smaller molecules. So when you drink water, you actually hydrate yourself. When you look at a molecule, and we're going to do a basic demonstration. If I got a molecule this size, and I've got a molecule that size, which one am I going to absorb better? I'm going to absorb the smaller one, all right? So drinking a higher pH water is going to help you absorb and hydrate better, okay? That's one of the things that people notice right away, is that they hydrate better. They feel better because they actually have the right amount of water in their system. Now, there is another reason that's important. Our body takes minerals from the water and it absorbs them, okay? This is very important natural, cycle for our bodies. But it's interesting to note that when we're really ill or we're sick, and I'll throw it out as a question, do you think our bodies are more alkaline or more acidic? They're more acidic, okay? There are several studies that show that if you're fighting infection, you're not feeling well, there is a correlation to how much acidity there is in your body. Now, it's my simple view. I'm not a doctor. I'm not anything like that. I'm more of a geek than anything else. But it makes sense to me that if your body is in more of an acidic state to fight off an infection, it would be better over time, once you've gotten better and you've healed, to try and reduce the acidity in your body so that it's not such a breeding ground for all of these things that seem to thrive in acidic environments. Does that mean that we should drink 20 glasses of elevated pH water a day? The answer is no, okay? As with anything, it's always good in moderation, okay? There is a place and a time to have an acidic drink, okay? Cranberry juice is a wonderful source of acid, and it's a great drink to have. It helps with kidneys, with all of those functions. But you want to start off slow. You want to have a little bit to start with for the first week, increase it a little bit more for the second week, until your body adapts. You never want to go from one polar opposite to another in a flash. You never want to remove your body out of a natural state. You want things to progress slowly so that you can accept the change and you can be healthier, okay? So one of the questions I get a lot, and I think it's important to cover this, is this something that we should give to little children or to really old people that are very ill? The answer is no. In a natural state, a child's body is pretty exceptional. There's a reason why our babies are always looked after. Their bones are like rubber. You hear that all the time. You drop them and they're fine. It's amazing. I wish I could fall down and be fine, but I'm almost positive I'd break something now. But kids don't need that in their system. By the time they're about 12, sure, you can give them a little bit here and there to help them keep that alkaline in their body where it needs to be. But then again, it's always a case of no excess, moderation, and let your body naturally start to absorb it and change. As I mentioned before, if you're older and you're very ill, you don't want to suddenly be drinking gallons and gallons of high alkaline water. It's never a good idea because your body's in such an acidic state. You want to take it slow, and you want to slowly bring those pH levels back to where they need to be. If anything, if I have something highly acidic and I have something that is higher up on the alkaline side, and I add the two together, what do? I bring them closer to a natural state or a neutral state. I'm not trying to make it high alkalinity. I'm not trying to make it high acid. I'm trying to just bring the body back to where it needs to be, a genesis of normal. All right, and that's really important. And there's several studies that talk about the benefits of higher pH, that talk about how it's good for our digestion, how it's good for absorption of water, all of these different things, and also in combating health issues as well. So, we will be talking about that in the future here, and this is just to give you an idea of how it works so you can feel comfortable and you can start to learn a little bit more. We've planted the seed, if you will. Okay. Any questions about water? And just a fact, some of the tests I mentioned earlier that we had tested several different drinks. Don't be fooled by the fact that something tells you it's good for you. Let's be honest, what is the best thing that you can drink in the world? Plain old H2O, plain old water. That's the best thing you can drink. It makes you feel better. It stops bloating. I mean, you just feel normal when you drink it. You don't, it doesn't add a lot of sugar into your system. It doesn't do any of those things. Your body can process water better than it can process anything else. So just remember that if you want to know what ground zero is, start at water and we'll go from there. So any questions on pH levels?
Alkaline water will actually pull the toxins out of your body then?
So alkaline water, it doesn't necessarily pull the toxins out of your body. Something that we talk about, and we've just glanced over it, ORP, which stands for Oxidization Reduction Potential. Do we know what antioxidants are? Okay, antioxidants attract oxidants. Okay, they pull them out of the body and they get flushed out of the system. All right. Water that has a negative ORP reading of about 200 or more acts as an antioxidant. That's what it does. It absorbs those oxidants and it removes them from the system. Now, there is a correlation between oxidants in the body and longevity of life, health, things like that. As I said before, I'm not an expert. There are just studies that show correlation between that. This water actually comes out at about a negative 300 to 320 ORP level, so it is going to promote the reduction of oxidants in your body, is what it's going to do. And that is going to help fight off infections and things like that.
I've read a lot of different studies that talk about how people that have cancer, that cancer can't grow in acid levels. Have you heard these studies about the drinking alkaline water if you have cancer and these type of things?
It's the opposite. It's not that it can't grow in acidic. It does really well in acidic environments. Cancer, and once again, not an expert, but from what I've read and what I've seen and what some of the experts have said, the correlation is that acidic environments promote cancer, the growth of. Alkaline environments don't promote that. So if cancer does well in an acidic environment, it would be better to promote an alkaline environment. So what you're doing is you're using a little bit of intuition and common sense to say, okay, if it thrives in this environment, we're going to slowly change it to this environment and see if we can help combat it.
My question is, if this is the only option for someone, if this is the only option for clean water, say their water system goes down and they have to get water from the lake or the creek and filter it through this system, is it okay for then families, children, parents to drink this water at all times if this is their only option for clean water?
You know, if this was your only option of water, yes, it's going to be okay to drink. You're not going to want to drink it for prolonged periods of time, but what you're talking about is an emergency. Is it better to drink filthy water, or is it better to drink water with a slightly alkaline base? I'm going to go with a slightly alkaline base. Emergencies, thankfully, do not last forever, so it gives you a clean source of water and it allows you to be able to have water that you can use. If it was going to be a prolonged emergency environment where you didn't think you were going to have water for several months, you can actually remove the final filter, which increases the pH level, and all you have is beautifully purified water that anyone can drink. So if it is a concern to you, because we all know that we love our kids and we care and we want to make sure it's safe, you can actually remove that filter out of the system if you want to.
All right, so you've been talking about all the different contaminants that have been taken out by this unit. Does it take out radiation?
You know, it does not take out radiation. It focuses more on the heavy metals, colors, odors, solid particulates, bacteria, things like that. But it is not designed to take out radiation, no.
All right.
How does your unit compare to other atmospheric generators out there?
So that's a really good question, okay? Not because I get to blow my own trumpet kind of thing, but because most atmospheric water generators function exactly the same. There are actually only a very few groups of people that make the actual atmospheric water generators. The technology is all the same. It's been around for a while. What makes the difference is what you get out at the end. Do you get water that still needs to be filtered? Do you get slightly filtered water? Do you get perfectly filtered water? Or do you get water that's not only been filtered, but also had the pH raised and the water's been ionized? These are important things to kind of know, because you've got to be able to compare apples with apples as opposed to apples and bananas, or oranges, or pears, or peaches, you know. There are several different units available. The most important thing to remember is, what does that unit do? Okay? If you're looking at an average system that just produces water out of the atmosphere, you know, great, that's what you're going to get. You're going to get a dehumidifier, basically, that you have water that you can filter. Those are going to be less expensive than systems that would filter the water to a certain degree. And then those systems that just filter the water after producing it are going to be slightly more, but still less than those systems that increase the pH and the ionization of the water.
Some of the units that do take the water from the air and also increase the pH, what do those usually run at?
You know, I've seen a lot of different pricings on them, and it's always hard. The internet is a wonderful tool. There are so many questions you can ask and so many answers you can get, but with unfiltered information comes a great responsibility. You never know what you're going to get. I've seen anything from about $3,000 all the way up to $6,000, $7,000, $8,000, depending on the name brand, depending on how good they say it is, types of things like that.
You mentioned that drinking this water you should start slowly. Do you have a recommendation on like how many glasses you should drink a day and what you should work up to?
You know, it's a personal preference with water and how you drink it and how your body reacts to pH increase. Some people have a higher pH than others. You know, it's a natural thing. We're all different. My personal opinion would be to start off slow, because it's not so much caution, it's just prudence. You know, pace yourself. I most probably would start off drinking about a quarter to a half a glass a day, and I'd work my way up over several weeks to a glass or two a day. Another thing that's important to note is when you would drink that water. I drink it first thing in the morning, a little bit before I ate, not right as I'm eating, because let's think about that for a second. Acidity is good to digest food, okay? So I don't want to mess with my acidity levels when I'm about to eat and digest and things like that. First thing in the morning, you get ready, you take a shower, you do all the things you need to do to get ready for the day. You've got a little bit of time to absorb that water and to get hydrated, and that's the other key. Hydrate yourself, you know, this is going to allow you to be more hydrated throughout the day. And then maybe a glass before bed, or, you know, a couple of hours after lunch or something like that, just to kind of balance out the amounts and when you're drinking it.
I have another question.
Now, caveat to that, or just a statement, there are people that drink a lot more than that a day. You know, like I said, it's a personal thing. It's how you feel and how your body adapts to it.
So it's not going to physically hurt you or anything. Will you feel any effects if you, say, have drank 3 glasses?
You know, you actually feel effects no matter what you do, because your body's not used to having pure water in its natural sense, okay? So you're going to hydrate better, you're going to have more energy, you'll be able to benefit from issues like diabetes and things like that. You'll find that your body does adapt and change. There are no side effects, because this is more of a natural procedure. This is not a shoot electricity at it and do all these crazy things. We're not creating an unnatural source of water. We're basically imitating pure water that's run over several different types of minerals to be able to absorb the benefits of those minerals, is what we've done. Bear in mind, the only electricity that is used in this system is to power the condensator and the pump, not to mess with the actual water. That's really important to know. There are systems out there that can play with the water, and that's when it becomes an experiment, you know? That's where you want to be careful. But no, there are not going to be any significant issues with raising the alkalinity in your diet. Obviously, precursor or disclaimer, everybody's different, and there may be someone out there that has an intolerance to that. So, you know, you've got to judge it yourself. You want to just make sure that you take it slow and you increase it over time and promote a healthier, you know, a healthier person, a healthier body.
Would this work with your well?
Yes, this will work with a well, okay? There's two ways that it can work. If the well has got pressure to it and I can push the water in by connecting it to some pipes or something like that, it'll work fine. But remember also, I can always take the water out of the well and I can pour it into the back and filter it through. So yes, it will work with a well, just like it'll work with a lake or a creek or a stream or anything like that. Yes, another question.
I have a question. Is it possible to be allergic to any of the things in these filters, or?
You know, not that I'm aware of. I have not heard of anyone being allergic to filtered water before. But like I said, you know, we all have different bodies, so there could be a possibility out there, but not that I'm aware of, no. All right, we've talked about a lot of things, and something I just wanted to touch on. I have a home that's from the turn of the century. It has older pipes in it. And one of the reasons I think this is so important is that it's good to have filtered water. Now, granted, my water comes from the city, but you've got to think about the fact that the city traditionally, or a municipality, or whoever does it, whoever treats my water is going to use several harsh chemicals to scrub the water. And although that's a good thing because I know the water is potable and I can drink it and I can cook with it, do I really know what I'm ingesting? You know, do I really know what chemicals I'm taking into my body? You think about what they've done to kill everything. They're killing everything, both good and bad. You know, and it's I think it's important to know what you're drinking and where you're getting it from, and have the science behind it to prove that it's good for you and that it's clean water. So I just wanted to point that out because that's one of my personal perspectives. What I would like to do is I'd like to do one more pH test. Earlier, I asked Ethan to grab me a cup of water from just from the faucet or the tap. And Ethan, can you bring that up here? And we're gonna do one more pH test just to see how it performs. So we're gonna move these out of the way here. All right. So this is just regular tap water from here. Now, it's interesting to note that you guys pull your water from underground here at Morningside. So one of the benefits is that it actually is going over the different rocks and things like that and absorbing minerals from the water. So it should have a pretty decent pH reading. It'll be slightly alkaline. All right, so we're sitting at about a 7.7. Yesterday we were getting readings at about an 8. So we're right in the range there. Now this water is obviously treated because you don't just pull water and drink it. It has been treated, but you know that's just a good indication. It gives us just another reference point for all the pH tests that we've done. We're sitting at 7.7. If you can see that over there, 7.7 pH. All right. Okay. So what I would like to do for my final magic trick, I'd actually like to invite some people to come up and try some of this water. And how we're going to do it is we're going to test just some regular bottled water that you get from any old store, and then we're going to test some of this water. And I just want to get your feedback on how it tastes, and see what you think. So let's set out some cups here. We'll do three different folks. Once again, listen carefully. Oh, there he goes. Look at that. It's a sealed bottle of water. I'm not magically resealing my water. All right. Let's see. Would you like to come up and try some water? Would you like to come and try some? And how about you, sir, in the back there? Would you like to come try some water? So I'm going to move out of your way. Why don't you all grab a little glass there and taste that water and tell me what you think. I'm pretty sure you've had some before, so it's not going to be a shock or anything. It just tastes like water, doesn't it?
Yep.
Yep, tastes like water. That's good. At least we know we're using water. That's always handy. So now we're going to do the same thing, and you can keep that cup. Don't finish it all the way because I want you to be able to taste back and forth. We put it on the magic box here, and we're just going to press the water button. All right, so there is one for you. Let me get out of the way here so that you guys can see. Let's do another one here. That one is for you. And then just remember which one's which. Don't mess them up or confuse them. And this one is for you. Okay, have a taste of that and tell me what you think, if you can notice the difference. Tastes a little bit different, doesn't it? Mm-hmm. The only way I can describe it is when I was a kid, there was a stream that went over granite rock. I don't know if you know what granite rock is, but the water always tasted crisper. That's the only way I can describe it. It's got an actual taste to it. I really like it. I think it's very refreshing. There's no sense of chlorine. It doesn't. Sometimes water leaves your mouth feeling dry. Have you ever drunk water and it leaves your mouth feeling dry? This doesn't do this. It's most probably because of the absorption rate. But there you go. Yes, you had a question or a comment.
Well, what I wanted to say was, I think the most amazing part of this is this came from the air. This did not come from tap water. It didn't come from lake, creek, nothing. This came out of the air, and it's delicious. And I feel a difference in my mouth with the moisture of it. So it's good.
It is. It's quite an amazing thing to think that we pulled that out of the air. It's a miracle almost. So yeah, pretty cool. All right. Thank you. Well, thank you very much for listening. I really appreciate it.